Hello, this is Scholar Strife doing some math. Today in geometry, we'll be looking at some angle relationships in circles. So let's start off with a circle. And let's put a few points on here. Okay. So we got AB, we got the line EC, and let's toss it into here. Okay. If a tangent, so EC the tangent, and a chord, so AB would be a chord, intersect at a point on a circle, so they intersect at point B, then the measure of each angle formed is half the intercepted arc. Okay, so we're talking about angle ABC. Let's use colors. Angle ABC right here is equal to half of this arc. Yeah, half of arc AB. All right, and the other piece ADB. So we're looking at this angle here and this arc here. Angle ABE is equal to 1/2 of the arc ADB. And I will be right back. Oh wait, the noise has stopped. There's a noise. 1/2 ADB. There we go. There. So the red angle there is half of the measure of the arc ADB. Alright, the next theorem. So let's draw another circle. And let's have, so here's the center. Let's have this going on. And this. So let's call this C, D, A, and E. So if two chords intersect to form an angle inside the circle, not at the vertex, so not at the center of the circle, then the measure of any angle formed is half the sum of the measure of the arcs intercepted. So let's look at, B is in the middle here, sorry. So let's look at this arc here, or let's look at this angle. Let's call this angle 1. So angle 1 is going to be equal to, I should have moved the circle over to the left, but angle 1 is going to be equal to these arcs here. Red. So arcs 1/2 of arc CD. Sorry, I'm going to make some more room. Yeah, let's redraw the picture. Okay, we have the center. These guys intersect. Not in the center. C, D, E, A. And then this is angle 1. Angle 1 is equal to 1/2 of the red arc plus 1/2 of, or 1/2 of the red arc plus the blue arc. AE. And so angle 1. So these angles would be the same, angle 1 and that one, because those are vertical angles. Angle 2 would be equal to 1/2 of AC, so the upper one, the upper arc, and the lower arc, DE. So what if we have angles outside the circle? Okay, so here we have a tangent and a secant. If it's a tangent and a secant and we're looking for that outside angle here, then it's equal to 1/2, let's use colors, BC and AC. Okay, so 1/2 red minus blue. Okay, if we have two tangents, tan, okay, then it's red, 1/2 of red minus blue. Or we can have two secants, and once again, red minus blue. 1/2 of red minus blue. Secant. Alright, example 1. Line M is tangent to the circle. Find each measure of angle 1. Okay, so what the first theorem said is if we have a chord and a tangent intersecting each other, then this angle here is equal to 1/2 the arc, its intercepted arc. So 1/2 of 132, which is 66 degrees. Part B, same thing. We're looking for arc EFD. Okay, so we're going backwards this time. So we're looking for this arc, which corresponds with this angle here. Okay, so that is 110. So our formula is that angle, 110 degrees, is equal to 1/2 arc EFD. Okay, so in order to find that, we just double our angle. Arc EFD is equal to 220. So if we have an angle, then we take half. If we're looking for the arc, we double the angle. Okay, example 2. Find the value of x here. Okay. JH. Okay, let's do that. I'm going to make these arcs red and these arcs blue. Okay. If we want to find the angle X, that's going to be equal to 1/2 blue arc plus blue arc. Blue plus blue. So 1/2 of 112 plus 140 is 1/2 of 252 degrees, which is equal to 126 degrees. Okay, let's do some more. All right, here we go. Measure of arc ACB. So right here. Oops. That arc there. So the angle, 120, is equal to half the arc. So we're going to double it and make it 240. Part B. So we know that this is 52 degrees, that's 52 degrees. Okay, we're looking for that arc over there. Okay. So once again, I'm going to color code these. So these arcs correspond to the 52s. These blue arcs correspond to this angle here. So we need to figure out what that angle is. We're going to figure that angle, 52 plus, let's call this y, is equal to 180 degrees because they form a straight line here. 52 plus that angle is a straight line. So y is going to be 128. Okay, so now that we know what that angle is, so this angle, 128, I can now use our formula that says our degree, 128 degrees, is equal to 1/2 the blue arcs added together. Blue plus blue. So 128 is equal to 1/2 of x plus 144. Okay, to get rid of the half, we're going to double both sides. So I got 256 equals x plus 144. Subtract 144 over, and we'll get x equals 112. Example 3, find the value of x. Okay, so this one, we have an angle outside the circle, and all we need to do is take 1/2 of red minus blue. So x is equal to 1/2 red minus blue, which is equal to 1/2 of 98, which is 49 degrees. Example 4, you're flying on an airplane for about flying on an airplane about 5 miles above the ground. So 30,000 feet in the air-ish. If the radius of the Earth is about 4,000 miles, what is the measure of the arc BD? Okay. And there's the picture here. We're in this airplane about 30,000 feet. We're 5 miles above the ground, traveling around the world. Oh, they say the radius of the Earth is 4,000 miles. What is the measure of arc BD? Okay. So we know that this here, CB and CD are tangents. So CB and CD are tangents. We know that AB and AD are radii. So those are both 4,000 miles. So that means this is a right angle. And that's a right angle. That comes from them being tangents. Okay. Okay. So I have two right triangles and some distances. So what we're going to do is this. We're trying to find the arc BD. So let's color code that. Let's use this yellow here. So we want the measure of that arc. Okay, in order to do that, we need to find some sort of angle. And my goal is I'm going to find, let's mark it in green, I'm going to find this whole angle here. Because that'll be the central angle, and that'll tell me the arc measure. So what I'm going to do is, I'm going to split into two triangles here. And so here's the left triangle, CBA. We know that this is 4,005, and we know this is 4,000. Okay, so using from our past chapter, we're going to be able to find angle A. So let's make that blue. So to find angle A, we're going to use two sides that we do know. We know this side, 4,000, and the 4,005. This is the hypotenuse of the right triangle, and this would be the adjacent side, making this the opposite. So, using SOHCAHTOA, we're going to use adjacent and hypotenuse, which is cosine. But since we're looking for the angle, we're going to use inverse cosine. Or let's go back up a step. So this is cosine of angle A is equal to adjacent over hypotenuse. So this would be cosine of A is equal to 4,000 over 4,005. And then we take the cosine inverse of both sides to give us our angle, which is about 2.86. About 2.86. Okay, so this little blue piece here is 2.86 degrees. Okay, so that means the whole piece would be double that. So we're on our way to the green, so times by 2, 5, 2.86 times 2 is 5.72. And that is our answer, because of the green central angle, that is the same as our yellow arc there. They have the same measure, so 5.72 degrees. Okay, that was a more difficult one because we had to use past sections, past material to figure it out. And the picture made it a lot easier. Checkpoint 2, find the measure indicated or the value of each variable. Okay, part A. So that 26 degrees is equal to 1/2 of red minus blue. Another way to think of it as the big arc minus the small arc. So y minus 30. I'm going to double both sides to get rid of the half. So 26 times 2 is 52 equals y minus 30. So y equals 82 degrees. Part B. Okay, let's see what we got here. 2. What are they putting? 2 here. Trying to, what are they? 1 second. Ah, okay. So this is just like our Earth problem there. Flying airplane. So we want to find the measure of this arc here. Okay. And they give us... So in order to find the red arc, we need to know what the blue arc is. Because if we know what the blue arc is, we'll take that minus 360. Because 360 degrees in a circle. There's only the red piece and the blue piece, so to find the red piece, we just subtract the blue piece from 360. Okay, so what we're going to do is we need at least 2 measurements. So they tell us that this little segment here is 2, the radius is 4, so this piece is 4. So I'm going to go ahead and redraw my triangle really quick, one of the triangles. So this is DCE, so the top triangle. Got a right angle here, this is 4. This whole piece here is 2 plus 4, which is 6. So in order to find the blue angle, blue arc measure, I'm going to find this blue angle here. So looking at E, we have opposite side. So this is the opposite side. This is the hypotenuse, and this is the adjacent side. So we're going to go ahead and use cosine again. Cosine of angle E is equal to adjacent over hypotenuse. So angle E is going to be equal to inverse cosine of 4 over 6. So we put that in our calculator, and we'll get 48.2 2 degrees. Well, it'll give us only 1/2, so we're going to double it to get the blue. So times 2, and that'll give me 96.4. Okay, so that's the measure of the blue arc. To find the red arc, take 360 degrees minus our blue, which is 96.4, which is about 263.6 degrees. Hopefully that helped you out. Have a good day.